All right. Come in, take a seat. That's very dark. Okay. All right. I'm actually happy more people showed up because a couple of minutes ago there was just a completely filled back row and I felt like I was going to present to a jury or something. So thank you all for joining. Before we get started, quick show of hands. Who is here just to see Doom on a big screen? All right. Who is here to learn about the technology that we've used to do this? All right, okay, that's something. Okay, well, since we are in the age of AI, I tried just asking Bing Chat, which is powered by ChatGPT-4, to port Doom over to MAUI for me, because Copilot can do anything, right? And it just told me that I should do this myself. So, okay. Let's go. So this all started, this whole story, the fact that I'm here presenting to you about Doom on MAUI, this all started with a friend of mine called Wesley. And you might run into Wesley online or at other conferences. He's a pretty well-known guy in the .NET world as well. And he came to me and he told me, hey, I'm doing this thing. I have some spare time. And I'm trying to port Doom, which is open source, it's written in C. I'm trying to port it to C#, to .NET. And you know what would be fun? If we would have a MAUI version of it. What do you think? So I cleared my schedule a bit, and we went to work. We spent quite some evenings building this, talking about this. And before we dive in to all the technical stuff, I want to set some expectations. This talk is not how we ported the actual C code to .NET. That's what Wesley did. That's not what I did. He's way smarter than me. What I did is I took his WPF code, .NET code, and I ported that to cross-platform MAUI code. And that's what this talk is about. So just to set some expectations. If you are expecting to see C code ported to .NET, that will not happen. Right? You can still leave if you want to. So first of all, hi. Glad to see everyone here. My name is Nico. I'm a .NET architect in Belgium at a consultancy company called Initum. I've been a Microsoft MVP since 2014. And I run a local user group. I write some books. I drive a bike and whatnot. That's not important. We're here to talk about MAUI. Who does not know MAUI? Has never heard of or worked with MAUI? All right, a couple of people. Good. Who has never heard of Xamarin Forms? Couple. Okay. So for those who know Xamarin Forms but don't know MAUI, MAUI is the next version of Xamarin Forms. Easy as that. For the others, when I talk about MAUI, it's not the island in Hawaii or city in Hawaii, whatever it is. It's not that. So not this one. A couple of years ago, Microsoft decided, let's rename this well-known framework called Xamarin into something no one knows called MAUI, and let's make it difficult to search for it. Because if you search for MAUI, you get stuff about the place. But of course, if you go searching for problems with MAUI, this microphone is skipping out quite a lot. If you go looking for problems with MAUI, then we're getting somewhere. Yeah, just to show the renaming of the framework, not everyone was happy with it. There are some issues with it, but hey. So what is MAUI? MAUI is a .NET-based framework. It's based on Mono. It allows you to build native mobile applications. Native iOS, native Android, native Windows, native Mac Catalyst. But with C# and .NET underneath. And this is how it works. So you have your own code completely at the top. Underneath is the .NET MAUI cross-platform framework. Underneath that is .NET for Android, .NET for iOS, Mac, WinUI 3. And .NET MAUI is basically an abstraction layer over all those platforms. Underneath that is the base class library of .NET, and then we have the mono runtime, and then we are at the platform, Android, iOS. Just a very high-level overview, just to show you that this is really native. You are writing one language using one framework, but you are writing native applications for every platform, right? Okay, so from this moment on, until the end of the session, I will have 2 more slides. The rest is demo. What I did to show you how we tackle this, I went back through our commits. This is all open source, it's on GitHub. I'll add the link at the end of the presentation. I went back through our commits right until the point where I started doing the MAUI stuff. I went through everything, and I'm going to just replay what we did, right? So we are starting, and let me put it up here. We are starting with a solution that is basically a WPF project. If I run this, and we wait a second, here we go. So for the people who want to see Doom on the big screen, yeah. If I remember how to control it. So this is all .NET code. This is pure C#. There's no C code left anywhere. And even mouse control. So no MAUI in here yet. And this is where this talk actually starts. To save some time, I do have some snippets that I will copy paste in, and I will walk you through the most relevant, important parts. But maybe a small spoiler alert, we have reached the limits of what MAUI can do. We have found, we have hit walls and tried to find our way around it. It's been a really interesting exercise. But of course, everything starts with adding a new project. And we are adding a MAUI app. Don't worry, you can't read this. It's just adding a new project to the solution. doom-maui. Oh. There we go. .NET 7, it already exists. Come on. Since when? Apparently since this morning. All right. While this is creating, there are already 2 projects in the solution. One is a WPF project called .windows. Let me zoom in a bit on that. And the other is just a .NET class library. And this is the actual Doom engine being ported to .NET. So let's have a quick look at doomgame.cs. I'm guessing that's too small for the people in the back. Let me quickly increase my font size. Is this fine? Yeah, all right. So the main method in the Doom engine is the run method, which is right here. And what this does is it goes looking for what version are running. And what do I mean with a version? There are several versions of Doom. You have the shareware version, you have the full version, but also Doom 2. Doom 2 is just a version of Doom 1 with separate levels. It's the same engine, with some tricks left and right. But these are all the different versions that you can have. And how do we determine which version is being loaded? It's because the game needs a WAD or a WAD file. And WAD stands for where's all the data. And it's basically a binary file that contains all the sprites of the game, all the levels, the enemy placements, that's all in that one file. So the only thing the Doom engine does is load in that file, puts everything in the right position according to the data in the file, and then it just responds to events. That's it. So that's here as well. All right. To load the WAD file, it needs a path. So we have an environment variable that points to where the file is. And I can show you real quick. If I remember where it was, demo. Here it is. So this is the file. It's about 4 megabytes in size. This is the shareware version of Doom. There are tools out there that can read and manipulate this file. You can just look it up. This is also how modding and building your own levels works. It's manipulations on this file. All right, now let's see what's in the XAML. This is the XAML. This is everything. Everything that you saw on screen when I pressed play, this is it. It's basically just an image. And what we do is we refresh the image, the actual bitmap that it binds. So you have a binding here to an output. And output lives right here somewhere. Here it is. It's writable bitmap, and we swap this bitmap out several times a second. And that's why you get movement in an image. We'll dive into some more detail when we get to it. But for now, this is everything that we have on XAML side. In code behind, we initialize the game, and we call the run method that I already showed you. So this will check which WAD file is there, we'll load everything in and start. We handle key down and key up events. Do keep in mind that this is a game we're playing. Like in a normal application, if you want to add shortcut key support, like keyboard shortcuts, F3 to do something, whatever, you just need the key down event. That's enough because you just press it and release. If you're playing a game, you need to know how long the key has been pressed because you want the player to keep moving forward until it releases. So you need both the key down and key up event. And this will be important later on in the session. So as well, translate keys. Is this microphone dropping out every once in a while? Yeah. Is it okay? Can you still? I'll try to shout when it falls out. So we need to translate the actual keys from the keyboard to the keys that the engine understands. So that's what this method does. And then, where is it? Every time a key is pressed, we add an event. There's a main view model, and that has a list of events, which are input events. It's a queue, basically. So we add events to it, key press events, because we want every event to be handled. There can be no events that get lost somewhere down the line because of race conditions or something. Queue every event in the queue. Then we have the time. We have a timer running in an infinite loop, and at every tick, it will dequeue the next event. It will pass it through the engine, and that will do its thing with it. That's how it works. Now, for the actual drawing of the game, we have two important methods. And the first one is update palette. And for this, I'm going to switch back to the slides real quick and show you this one. So the building of the screen of the actual image in Doom is based on the index 8 pixel format. What that means is you have a palette of colors. Like this is the simplified version, right? So you have a palette of colors, 256 colors. They each have an index. Then you get your bitmap. But instead of containing actual data, it just contains the indexes. If you create a bitmap, it will take all the indexes and fill it in with the data from the palette. And that's how it builds your screen. The palette remains the same mostly throughout the level, and then we just swap out the different indexes. Now, we don't need to build this ourselves because we are using, in the WPF version, the writable bitmap class, which has support for index 8. So what we're doing is we are getting the palette in this method as a parameter, and we create a new palette output, which is a writable bitmap that contains that data. The screen ready event will trigger every time we want to update our frame. And this is all not so very important, but this is. The bitmap is what will actually be shown on screen. We write pixels to it, we give it the rectangle where it needs to write, and then we pass it in the palette. And then it knows what to do with it, and it will fill in all the indexes, and all the magic happens behind the scenes for us. So, where are we? All right. Now we need to move all this into the MAUI project. So, first of all, there's a bunch of logic in the core project. That's a class library. We can use that. So let's add a reference to the core project. There we go. Let's start by setting this as a starter project as well. There we go. We need the view models, and we also need a main window, I guess. Oh, it's just the view models. Yeah, we need the view models in there. There we go. We don't care about the console view model. The console view model is, I don't know if you've seen it when I launched, but there was like a console behind that showed all the logging. We're not bothering with that one in MAUI. All right. Let's start by updating our namespaces to make sure everything's correct. We have the main view model and a view model locator. All right, so far so good. Let's look at the main view model. Not so good, especially if you close it. There we go. Big problem. Writable bitmap is not supported in MAUI. It's just not there. So we can't use that. That was the first major challenge that we had. Okay, so we went looking for replacements, and there is this MAUI graphics library which offers some things, but not enough. It did not suffice to replace writable bitmap. But there's a different library that could help us. There is the pause for suspense. Skia Sharp library. And which one do I need exactly? Skia Sharp.views.maui.controls. This one. So Skia is a drawing library by Google, if I'm not mistaken, that allows you to draw whatever 2D stuff on screen. And Skia Sharp is a .NET version of that same library. It's being updated. Other platforms like Avalon use it to draw their controls. All right. With that installed, we can replace writable bitmap by a SK bitmap, a Skia Sharp bitmap. It does work a bit different, but in the end, it does what we need it to do. So I'm going to start by replacing writable bitmap with SK bitmap. We don't need this one. We're going to put these two in comments. So what this line does is, since we are triggering from different places in the code, we might up on different threads, right? And we are writing to the screen here, so we need to make sure that we are on the UI thread. In order to make that happen, we can invoke, or we can use our dispatcher to invoke something on that thread. That works in WPF, works in MAUI as well, but it's, instead of invoke, it's called dispatch. And then, right, pixels, we'll put this one in comment as well for now. Call it dispatch. All right, getting there. The only error left in our main view model is the int32 rect. This is a class built in for WPF. It doesn't exist for MAUI. But it's a very simple one, so we can just create it. And just to save some time, I'm going to jump to my script and copy it. There we go. So it's basically a rectangle. It takes an X and a Y position and a width and a height. That's it. And with that, my main view model is error-free. It doesn't work, but at least it can compile. All right, bitmap right pixels. Where is that? So we are in this screen ready. So this is where we're going to draw on screen. And the right pixels method that we have here is for right. We don't have that in Skia. So we will replace it with bitmap equals sk bitmap.decode. Thank you for that. And we pass it in the output. All right, for now, this is good enough. Let's jump to the main page. So to save some time, I'm gonna jump here into a folder I've prepared, and I'm going to copy that into the project. And we're going to add, replace some files, and I will walk you through the important bits. All right, for starters, let's jump back to the WPF. In the uninitialized, we started the game by calling run. Doom game version that I copied in, and instead of run, we now have run async. And this one has an overload now that takes in a game mode and a file name because of the way that MAUI handles files. So we had to load in the WAT file in WPF, but that doesn't work in MAUI anymore. You need to embed extra files into your application itself. You can no longer point to just any location on disk. And to do that, I will just add it here as an existing item. Go here. Select all the files, put it in there. There we go. So in a MAUI project, the resources file is where you put extra resources. Any image that you want to show in your application, any text file, anything extra that you want, you can just place it here. All right, let's see where we are. I'm gonna take the run async into the MAUI parts. In WPF, it's in on initialized. In MAUI, that doesn't exist, but we can override on appearing and put it in there. Needs to be async, of course. There we go. So basically, we're at the point where we can just run. Let's see if it can compile for starters. Huh. Oh, there we go. So MAUI hasn't been all that stable so far. In that it has that software development is not an exact science. And ever since this morning, whenever I try to build a MAUI project, I get this error. And I have no idea what it means because that workload is really installed on my machine. So I'm afraid I might not even be able to show this. Well, I do have a finished version installed on my machine, so I can show you that, but I cannot run from debug. MAUI won't let me anymore. This worked fine yesterday evening, by the way. But that's okay. Well, let's continue. All right, let's take our first snippets. Main page, replace. I can try rebuilding. You never know. So this is our new page. No, let me just show you. This is what the MAUI version would look like if it would run now. So we have software keys. We have the actual game running. Looks pretty high speed. So these are software keys. They work. You can click them, whatnot. That's what you would see now. They would still not work because that code's not there yet, but something would be. The SK canvas view is a control coming from the Skia Sharp library. And this is what's rendering the Skia bitmap now. And the combination of those two, what replaces our writable bitmap and the image control. For the other parts that are on screen, we have the game control, and game control is a user control that basically is an image that contains a key. On those images, in a bit, if I... so a bit later on, those get a trigger that if they are clicked, they will fire an event, and by that extra key property, we will know what button was clicked. That's why we have that. For now, we need to change our code behind a bit, because this shouldn't still be working. We need to pull the identify version of, so to select which WAT file we have, we need to pull that into our MAUI application and put this in here. Different ways that MAUI and WPF handle files on disk. The main goal of this was to have a working version on MAUI, but also keep the WPF version working. So I needed to pull some stuff out, add some abstractions, and so on. So what you're seeing here on line 26, the app package file exists async. This is a pure MAUI Windows way, or just a pure MAUI way of doing things. This will not work in WPF. The version that's there in WPF work on MAUI, so this is duplicate code with some minor differences, but there was no way around that. Let's pull in the next snippet. Add some usings. Need to create this one. Like that. So the view model locator, let's have a look at that one. That's just a class that contains a reference to the main view model, an easy way to get into that specific main view model. This pattern is very lightly based on MVVM, but it's not pure MVVM. So it's a bit of taking whatever we can use out of the pattern and just use it because it's faster. This is not the best or most beautiful code, but it was fun. Okay, so what are we doing here? We are running our Doom game. So first we are identifying our version. So that's the method I just pasted in, and that will give me two things: the game mode I'm in and the path to the WAT file. I pass in those two values into the instance run in sync, and Doom will fire up. We are going. From that moment on, my two methods, my screen ready and my updates palette in my main view model, will start firing every once in a while, and they will trigger property change events that I will get here. And with this, I will invalidate the game surface. Now, the game surface is my canvas view right here in my XAML. So by calling that method, the Skia Sharp canvas view will know that it needs to update itself because the bitmap has changed. There's no trigger going from the bitmap to the control, but you can tell the control that it needs to refetch its binding so it can update. Normally, at this point in time, I would press F5, it would launch, you would see Doom actually playing. It would be slow. It would be quite shaky, yeah, like it's running on low FPS basically, which is silly because this is a 2020 laptop and the game is from '93. So find a way around that. And the way around that is right here somewhere. Let me just paste this in here. Need the main view model. The update palette. Screen ready is here still, so that needs to go. Oh, okay. No, let's take one step back. This is the code that would actually run it slow. That's what you get by not being able to actually run it. So Skia Sharp doesn't have support for index 8 either, like not built in. So we needed to build this ourselves. That's what we did with this code. So we do have the palette, which is just basically the byte array as we get it in here as a parameter. And then for every value we get in the output buffer, we go to the palette and we take out the correct index and position it within our image. And because we're doing this ourselves, in managed code is what makes it slow. But .NET is a managed framework, so not easy to find a way around that. By the way, funny side effect, if we run this, I think it's this one. Yeah, if we run this on Android, this is what it would look like. It would render perfectly fine on Windows, but on Android, it would run like this. The reason being that 2 of the RGB values on Android are for some reason, right here in the Skia Sharp implementation. So we actually, if you go to the GitHub and you go look into the commits, you will find some code that says, if Windows, then RGB, if Android, then BGR. Yeah, that was a funny side effect. All right, let's move on. I'm gonna skip this one. Oh, this one actually has it. We're replacing these with this. Add some musings, there we go. So this is the actual code that switched from blue to normal. Little different way of updating our palette or saving our palette into a field. Not too important. Instead of using a normal byte array, we're using a Skia Sharp color object. But this is what made it performant. So the screen was rendering slowly. The game was not playing as it should. So I did what every good developer would do, and I asked someone else to fix this. I went to Wesley, I told him, this doesn't work, can you have a look? And he came up with this. For those of you who don't know the unsafe keyword in C#, the block of code that's in the unsafe block there will not be visited by the garbage collector. It's not managed memory. You're on your own. This is you telling the garbage collector, I know what I'm doing, stay away. And he goes like, sure. But for those of you who have experience with C++, this will look quite familiar with all the pointers and stuff. I have no experience doing unmanaged code, so that's why I asked someone else to do it. This actually runs like I've shown on the demo when I made it run. That's what happened there. All right. So back to the code behind here. Okay, before we continue, the next slide. And this one, I'll put it a bit bigger. Okay, this is how MAUI handles or creates cross-platform XAML controls for all the platforms it supported. So here at the bottom, you have your native controls, right? Your native iOS button, your native Mac button, Android button, Windows button. They've put handlers on there. Handlers are just a class that takes a certain abstraction of this, puts it into .NET land, so to speak. They have different handlers for different platforms, and they consider iOS and macOS one platform because that's all UIKit. There's a handler platform, and there's an abstraction for those handlers, in this case, iButton. That iButton abstraction is implemented by their Microsoft MAUI controls button class, so the actual button that we use in XAML. That's how it trickles down. Why am I showing this? Because we can use these handlers to extend the possibilities of those built-in controls. As I've mentioned in the beginning, we need to know both the key up and key down events in order to keep track of what our player is doing. And that doesn't exist out of the box. In MAUI, with a button or with any control that you want to add a gesture to, you only have the clicked event. Clicked means this. Not good enough, so we need to extend it. And to do that, we go image handler. The graphic said button, but all my controls are images, so I'm using the image handler now instead of the button handler. We use the mapper dot append to mapping. So we are adding to the default mapping. In this case, we call it touch support, which is just a key. And then there is a handler image and action. There we go. And this needs to be called view in order for my snippet to work. We'll take this one, put it in here. All right, so what we're doing here is, this will now trigger for every single image that is tapped. But we only want this for the ones that are game controls. If we're on, let's go with Windows. On second thought, let's go with Android. Doesn't really matter. From this moment on, you're in a platform native country. So for Android, you need to do this to add the motion event actions up and down events. For Windows, you have the pointer released, pointer pressed events, or the platform view key up and key down events. And then you can add these to event handlers. In this case, they would just add key action, which I still need to add, which is also just a snippet. Which goes into the main view model, somewhere down here. So the onKey action translates the key again into a version of the key that is recognized by the Doom engine. It adds a new event in the events queue, and then the queuing and dequeuing will sting, and touch suddenly works. So that was fun. We're now at the point where I can run this on my Android phone, touch support works, the game works, everything runs. I could run it on Windows, the touch controls would work, I mean the buttons would work, the virtual ones, I could click it with the mouse. But of course, if you run this on Windows, I mean, this is a device, this has a hardware keyboard, you would expect hardware support, right? Wrong. The thing is, if we switch back to Windows, let me just add this. Don't worry about these for now, just worry about these. So, platform view, the ones that you see up there, platform view, that is my native WinUI 3 or Windows image control. Image controls have a key up and key down events. The key down event says occurs when a keyboard key is pressed while the UI element has focus. Key up when a keyboard key is released. This would be perfect, exactly what we're looking for, except it doesn't work. For some unknown reason, MAUI swallows these events. They never bubble up into my own code. They get swallowed somewhere in the framework. I've talked to the MAUI people about this. The people actually work on MAUI as a framework. I've shown them this. I've told them this. I've explained them this. They went like, really? Huh, that's interesting. And that was that. So to fix this, I added an extra keyboard behavior. Now a behavior is something you can use in MAUI to add extra behavior to, again, built-in stuff. With the big difference being, this is behavior that's really, really platform specific. So in this case, I have a keyboard behavior, and I'm specifying that this is unsupported on Android and on iOS. So this is purely a behavior for use on Windows. This is a bit of me being naive and saying that hardware keyboards don't exist on iOS or Android, just because I was focusing on Windows at that time. Now, how does this work? There are two files here. There's a keyboard behavior, and this is the shared part. This on all platforms. And then there's keyboard behavior.windows.cs, the next file down. When compiling a MAUI application, it will check for these file names by convention. It finds one that says .windows, so this will only be included in the build of the app. If it says .droid, it will only be in Android, .iOS, you get the point. So what I'm doing here on Windows, and I need to uncomment this. Huh, strange. This should just work. Doesn't matter, can't run anyway. What this does is, it's if you run a XAML-based application, what it does is it starts building a visual tree, not too dissimilar to running an HTML-based application. You get a visual tree of all the elements in there. And you have helper methods where you can manipulate that visual tree. You can inspect it, you can change it on the fly while running. So with the MAUI application, it's the same thing. You have a visual tree of controls. And if you traverse that visual tree, you go way, way up in the hierarchy, and you get on all the way to the top, then you are in native country again. You're in your shared MAUI land or controls. You find a native, in this case, WinUI, Windows control. That's what I'm doing here. I go all the way up until I find my root element, which is of type UI element. If you've ever done UWP, Windows 8, or WinUI, then you know that UI element is the base class of all the controls in that XAML stack. So I have a UI element. And why do I need a UI element? Because that's the element where the key up and key down events exist. And if I go all the way up until I exit things MAUI, and I attach my event handlers on that level, then it works. This might not look like much, but this is weeks of investigating this bug every evening. But I wanted to fix this. So what I did is I found those two events, attached event handlers, and I just invoke my own key up and key down events that I've declared here. And those get triggered right here in the code behind. I attach some event handlers to it. Somewhere here. There we go. And they just go to the on-key action on the main view model again. And this was the fun part on doing this. All the boilerplate code of handling inputs into the game and reacting to input in the game, that was all there. I just needed to find ways to get the correct properties, the correct events into my code and trigger that in the engine itself, and it was done. So again, to show you the time, this is the MAUI version, and we have, I'm playing on my key, full hardware key, while the software keyboard also still works. So yeah, the keyboard thing was definitely the major pain point in this whole operation. Getting everything to render was way easier because someone else did that. All right. With that, I am 2 minutes before the ending of my time slot, if I'm not mistaken. This was my journey into porting a simple WPF application into MAUI. Are there any questions? No questions? Then I would like to thank you all for your attention, and I hope you have the nice rest of the conference. Thank you.